Okay, today we want to do a short revisions on chapter 6 on locational break-even analysis, so that you have the idea how to calculate the break-even analysis and choose the locations. Okay, so you can refer to your notes. Okay, by using the formula total cost equal to fixed cost plus variable cost plus times with quantity. So first step is we make equations. We will do equations. Okay, for equation 1, total cost A is for Akron, equal to 30,000 plus variable cost, so times Q. Okay, this is the first equation. Right, second equation, total cost for B is for Bowling Green. Okay, 60,000 plus 45Q. This is the second equation. Okay, the third equation, total cost for C equal to 110. Okay, forgot this one. Plus 25Q. Okay, this is the equation. Alright, the next step, what we need to do is that we want to know the intersection point between 1 equal to equation 1 and equal to equation 2, which is total cost for A equal to total cost for B. So 30,000 for A, 30,000 equal to 30,000 plus 75Q equal to equation 2 is 60,000 plus 45Q. Alright, so we will have here 30Q, 30,000. So Q, you may use X or Q, any other quantity. Stand for quantity, or X, you can use any sign lah. Alright, this is for equation 1 equal to equation 2. So total cost for A, Akron will intersect at total cost B with Bowling Green at quantity 1,000. Okay, moving forward, we want to know the equation 2. Equation 2 equal to equation 3. Equation 3. So we want to know the intersection point between Bowling Green and Chicago. Okay, so for Bowling Green, 60,000 plus 45Q equal to 11000 plus 25Q. Okay, so we will have here 20Q with the 50,000 equal to 50. So Q equal to 2,500 units. Meaning that this intersection will happen between B, Bowling Green, and Chicago at 2,500 units. Okay, so next, how we want to make a graph. Okay, this is just a graph. Okay, so A is 30,000. So we have here fixed cost for 30,000, 60,000, 1,000, 110,000. Okay, so for A we have we estimate here lah 30,000. Okay, and then we just plot the graph. Okay, then second one, B is the cost. Okay, this is the cost. Volume quantity. Okay, 60,000. So 60,000 will be here. Okay, we just plot the graph. Okay, the intersection between this is B and then this is A. Okay, so here in our calculation, the intersection point between A and B is 1,000 unit, meaning that the intersections here will be 1,000 unit. Okay, next one, C. Okay, C is 100, 110. Okay, so it's gonna be right here. Okay, we just plot the graph. Okay, so intersection point between B, if you can see here, B and C will happen here, or intersection 2 equal to 3, 2,500 units. Alright, so how we want to interpret the graph. If you can see the line here, okay, so between these three lines, the lowest line is Akron. If you wish to produce product 1,000 and below, so Akron is the best. Akron is the best location is if your product 1,000 and below. Okay, first Akron is the best location for production. Unit and below. Okay, if you wish to have okay, let's look at this between this region 2,000 between 1,000. Okay, so the best location is, if you can see here, the purple one is for Bowling Green. So if your production, you want to produce if production between 2,050 at 2,500 and 1,000 unit. So Bowling Green is the best location. Okay, so here is Bowling Green. Okay, if you wish to produce more than 2,050, so if you can see the graph here, the lowest line or the lowest color is the C. C is for Chicago. So if you wish to have production more than 2,500 and above, or more than 2,500, so Chicago is the best location. Okay, so how to interpret? Okay, if your production more than 2,500, Chicago is the best location. Okay, that's it. How we want to interpret the graph or the calculations on locational break-even analysis.